got an idea that from leads 1, 2 and 3 you have a positive deflection. Now on the top left you have a green box which I've made. So a normal heart usually represents a cardiac rhythm which flows from 11 o'clock. So imagine a timepiece, 11 o'clock to a 5 o'clock axis. So it's going from 11 here to 5 o'clock here. So it spreads downwards, meaning that it's spreading towards leads 1, 2 and 3, because leads 1, 2 and 3 almost sits in that type between 11 to 5. So imagine the time ticking from 11 up here to 5 o'clock like this. So it's almost spreading down like this. So it takes leads 1 during from the hour turning from 11 to 1, and then 2 to 3 is lead 2, and then eventually lead 3 becoming 4 and 5. Okay, if that didn't make sense, then I have a different explanation. So we usually, on these three images, you can see how a QRS complex or a P wave and a T wave, so a simple complex, would look like on all these three leads. Now the key understanding is this little box here on the bottom screen. Now, as current travels towards a positive pole from a negative pole, usually there is a deflection upwards on the ECG graph. Now, that's a key information. Remember that. When current travels from a positive to a negative, or on the opposite direction, then there will be a negative deflection in the ECG graph. Now, when the current flows perpendicular to the lead, i.e. the waveform, then it goes in both directions, which forms a biphasic, which is sometimes seen on the ECG graph. Now, you might be confused of what current are you talking about. There's different types of current. Now, when you connect leads on the body, so for example, let's just look at lead 1. So lead 1 is, as you know so far from this video, is connected from the right arm to the left arm. So you have a negative pole on the right arm and a positive pole on the left arm. So current from inside the lead, not your heart, the current inside the lead, there's an electric current flowing through those leads, is flowing in this direction from negative to positive. Now your heart itself, the cardiac rhythm, the electrical activity of the heart itself has its own current which is flowing in this direction. So ultimately, penultimately, you can see there is some sort of, since the current is flowing in this direction from negative to positive, and your heart is also going in this direction, in lead 1 there is overall a positive deflection because the vectors eventually add up to positive, which I'll talk about in the next slide. In leads 2 and 3, this will make more sense to you guys now, is the current is flowing from the right arm to the left leg from negative to positive, so clearly it's going down in this direction, and the heart's impulse is also going down in that direction. Hence why in lead 2 you see a great or a really big positive deflection in the R wave. Now in lead 3 also you see going from negative left arm to left leg, negative to positive, and basically it's going again, the current is traveling towards so it represents this portion of the where my mouse is pointing to, again a positive deflection. Now when you come here, now things get a bit more confusing, because some people have this question, why is there a negative deflection in the Q wave, then there's a positive deflection in the R wave, then there is again a negative deflection in the S wave. So a QRS complex usually consists of negative, positive, and then negative again. Now the reason for this is, if you look at this image here where my mouse is pointing to, initially when the SA node brings down the electrical activity, you can see there is initial deflection towards the left side this way, which is more towards the negative side. So imagine your right arm, your negative pole being here, your left arm, which is a positive pole, and your left leg, which is a positive pole. This is going towards this side, more towards away or towards the negative side. So initially when the electrical impulse is coming down, it goes down the bundle of his to either side, the left and right bundle branches in the septae, and then there's a greater electrical influence on the right atrium initially. So there is a negative deflection, i.e. the Q wave. That's why, since it's going to the negative direction, hence why the Q wave usually starts with a small negative deflection. Now as you go further, as the wave starts to come down past the bundle of his into the ventricular walls, it becomes the vector becomes more greatly towards downwards, towards the apex of the heart, towards the ventricle. Now here you know there is a positive pole because of your left leg, so here this becomes a positive deflection, hence why the R wave is greatly positively deflected. Now then the impulse, as you can see from the GIF here, travels slowly upwards into the left atrium. Now the left atrium is much more muscular and thicker compared to the right atrium, hence why you have a left positive vector, so the vector is more greatly towards the left side. Again, this is positively deflected, but then on the ECG graph you'll see it as coming down. That does not mean a negative deflection. Negative deflection would mean that the line has to be beneath the isoelectric line. This is still a positive deflection. Lead 4 on the fourth one, i.e. the S wave, is going away now. As you can see from the image here, the depolarization was towards the edges of the top part of the heart, top part of the ventricles. So this is going back up to the negative side again, hence why there is a negative deflection. Hopefully you understand that. You don't need to understand this as a doctor or anything, because once you start looking at ECGs, you probably understand exactly how they work initially. But this is for those who are curious to understand exactly why there are negative and positive deflections within the different leads that you see on ECG paper. So the only thing I want you to remember is Q wave is here. The reason why it's negative is because the arrow is going this way. R wave is always positive. R wave consists of going up and a slope up and a slope downwards, and then the S wave is also negative.